Okay, so everyone go ahead and do the factoring and math knowledge question for today. Once you have finished, y'all can unpause the video and I can go over the correct answers. So for the factoring, you should have x minus 10 times x plus 6. And that would be your answer. For the math knowledge question, it gives you a lot of information, and then it says if the car stopping speed for an initial speed is this, per hour is 17 feet. What's the stopping distance for an initial speed of 40 miles per hour? You got to come back up here and actually read what it said. This sentence is the one that is important. The stopping distance of a car is directly proportional to the square of the speed of the car. That is the sentence that you need to pay attention to. So I'm going to do the stopping distance as a D, and it is proportional to the square of the speed of the car. And I'm going to do speed as S. And so it's S squared because it's the square of it. Not the square root, but the square. So it says the stopping distance for an initial speed of 20 miles per hour. So is the 20 the D or the S? It says the speed, initial speed of 20 miles per hour. So the 20 is the S. And then the stopping distance is 17 feet. So that is proportional to what is the stopping distance. So what is the D for the initial speed of 40 miles per hour? And I bet some of y'all saw 20 to 40 doubled and went 17, double that to get 34. But if you actually plug this in to your calculator, you should get 68 for your answer, D. So that would be the stopping distance that is required. Okay, so we're going to be looking at lesson 2 today in calculus. More concept review questions from pre-calculus, and then we're going to look at the graphing calculator. So if you need a graphing calculator, you can go grab one from over by the door. Just make sure to return it whenever you finish. So some of these questions from pre-cal will be review. Some of them are not even from pre-cal. They're really more from geometry or algebra 2, but you used them last year probably. And then hopefully you dealt with the graphing calculator some last year. Some of the stuff may be review, some of it may be new. So we want to find the coordinates of the point halfway between those 2 points. Coordinates of the point halfway between 2 points is the midpoint. Your midpoint formula, it is just x1 plus x2 divided by 2, y1 plus y2 divided by 2. I won't write in green on top of a green background anymore, sorry. So that's your midpoint formula. So our x values are -4 and 13. So we just add -4 plus 13 together and divide by 2. And then 7 plus y, those are our 2 y values. Add them together and divide by 2. -4 plus 13 is 9 over 2. 7 plus 5 is 12 over 2, which reduces to 6. So there is your midpoint. So that's how you would find your point halfway between the two. For this one, we want to find the distance between these 2 points. So we're going to be using the distance formula here. In case you don't remember what it is, I'll write it out. So that is one form. There are actually 4 different forms of it. You can switch x1 and x2, or you can switch y1 and y2. So there end up being 4 different ways you can write it. So it doesn't matter which one is your x1 and which one is your x2. You're subtracting and then squaring, so you're going to get the same number no matter which one goes first. So our first x that we're going to plug in here, I'm just going to do 4 minus a -2. which is going to become a positive 2, and then plus y minus a negative 1, which is going to become a positive 1. So that's the first step. Plug them in, and then you're just going to simplify it. 4 plus 2 is 6. Squared is 36. 3 plus 1 is 4. Squared is 16. 36 plus 16 is 52. And we always reduce our radicals if we can. The square root of 52 can be written as 2 square root of 13. So that would be the distance between those 2 points. For the next one, point-slope form of the equation to get it into slope-intercept form. So I'm going to go over the forms really quickly. Slope-intercept form is y equals mx plus b. Hopefully you're familiar with that. Point-slope form is y minus y1 equals mx minus x1. There's also general form or standard form, depending on which book you use. Sometimes they call them general, sometimes they call it standard. It just depends on the book. But that is another form for a line. So it says use a point slope form. So that's this middle one right here. And it says our slope is negative 2/3. That's your m. Your negative 2, 4, those are your x and y values, but your x1 and your y1 values, not the x and y. When you get done, you want to have x and y in your equation, so you don't plug in for x and y. So we're going to plug it into our formula. So y minus our y value is 4, and then our slope is negative 2/3 x minus a negative 2. So that's going to become a plus 2 here. So I'm going to have y minus 4 equals negative 2/3 x minus 4/3. And then I'm going to need to add this 4 to the right side. So y equals negative 2/3 x negative 4/3 plus 4. 4 is the same thing as 16 over 4. And so 12 over 3. And so negative 4 plus 12 is 8 over 3. And so that is putting it into slope-intercept form. So hopefully you remember that either from Algebra 2 or Geometry, or maybe both, and hopefully even from pre-calculus last year. Looking at this one, we want to write the slope-intercept form of the equation that goes through the point negative 4, 2 and is perpendicular to the point to the equation that they give us. So the first thing we have to do is to figure out the slope of this equation, and the only way to do that easily is to solve for y. So I'm going to say 3y equals a positive 2x minus 1, moving those two terms over to the right side, and then divide by 3. And so my slope is found here. The slope is 2/3. But it says perpendicular. Hopefully y'all remember this little symbol. That means perpendicular. Your perpendicular slope is the negative reciprocal. So negative, because this one's positive, and the reciprocal of 2/3 is 3 over 2. So this is the slope we're going to want to use. And we're going to want to use that line, that point to find the equation of our line. So if you took someone else for your other math classes, this is the first one you've taken with me, you probably haven't used this exact method to get it into slope-intercept form. If you've taken me, then this is what we normally do. Y equals mx plus b. Our y is 2. Our m is negative 3 over 2. Our x is negative 4. And we need to figure out our b. If you don't like this method, you are welcome to use whatever method you used in your other math classes. Plugging it into the point slope form is perfectly fine with me. You'll get the same thing. So 2 equals negative times a negative is a positive. 3 times 4, 12 over 2 is 6 plus b. And so b would equal negative 4. And it says write the slope-intercept form. So y equals negative 3 over 2. Make sure you're using the slope that you plugged into your equation to get that b value. The perpendicular slope, not the original slope that you started with over here. Don't use that one. That'll get you the wrong equation. So y equals negative 3 over 2x minus 4. And so that would be your equation. Okay. Moving on to another example, we are looking at completing the square. So I'm going to go back over completing the square. Hopefully you have done this before. I know some of you don't enjoy it. Some of you love it. You got to be able to do it because different problems require it. So I'm going to go over it. The first thing you want to do, x squared and your x term need to be on one side. The constant, this 1, needs to be moved to the other side. So x squared minus 3x, leave a space, and then equal negative 1. From here, we are going to take this number, negative 3, and multiply it by 1/2. We're going to take half of it, negative 3 over 2. And then you're going to square that number. So negative 3 squared is a positive 9. And 2 squared is a positive 4. And you're going to take that half and then squared number and add it to both sides of your equation. So you have plus 9 over 4 on the left side, plus 9 over 4 on the right side. From there, you're going to factor the left side. It is always going to factor in this form because we were completing the square. We were making it so that it factors in that form. The number that is going to go here is always this number times the 1/2, which is going to be right here, negative 3 over 2. Whatever the sign is here, that sign is going to transfer down there. So that's how it factors. And then on the right side, negative 1 plus 9 over 4. 1 is 4 over 4. So negative 4 plus 9 is a positive 5 over 4. From there, you're going to take the square root because you're trying to solve for x. So x minus 3 over 2, the squared and the square root cancel out. When we put this square root on the right side, we have to remember to put a plus or a minus. And then we don't like fractions inside of radicals. The square root of 5, we are going to leave as the square root of 5 because we can't reduce it. However, the square root of 4 is just a 2. So that's how you can rewrite square root of 5/4. And then from here, we just need to add 3/2 to solve for x. And so that is your x value right there. And so that's how you complete the square. Hopefully you remember most of how to do that. Feel free to stop and review with someone if you need help more specifically on that one. Okay, so it is the exact same equation, so we should get the exact same answer. This time we're going to use quadratic formula. So I'm going to write the quadratic formula. Hopefully you remember deriving it either from last year or maybe even from Algebra 2. You do not have to derive it in calculus. It will, on a test, ask you to state what the quadratic formula is, but it doesn't ever ask you to actually derive it on a test. So you don't have to do that. Some of y'all may remember the song that we used to learn it. Feel free to sing it if you would like, to tell anyone that has not heard of the song before so that they know it. They'll probably look at you like you're crazy. But you know your quadratic formula, so it doesn't really matter. So that's your quadratic formula. If you do not have this memorized, you're definitely going to need to memorize it because there are times where you need to use a quadratic formula and it's not going to be given to you. So it's always in the form ax squared plus bx plus c equals 0. If the equation is not in that form, you have to set it equal to 0 and put them in descending order in order to use the quadratic formula. So our b on this one is the -3. So negative b is going to be a positive 3. And then plus or minus the square root of -3 squared minus 4. Our a on this one is just an understood 1. Our c is another 1 all over 2 times 1. So if you simplify, you get 3 plus or minus the square root of 9 minus 4 over 2. And then from there, we can say 3 plus or minus the square root of 5 over 2, which looks possibly a little bit different than your last answer. But all you have to do is split it into the two fractions, and now it's exactly like what you got before. So you get the same answer. One of them puts it in two fractions, one of them leaves it as 1. I personally don't care which type of answer you have, the one on the left or the one on the right. 1 fraction versus 2, that doesn't matter. You just need to make sure you know how to do both methods. Okay, so now we're going to do polynomial division, long division. The x minus y is going to go on the outside of the house. That's probably what you called it back in maybe 3rd grade when you learned this. And then x cubed goes first, and you're going to want to leave a lot of space and then put minus y cubed. You don't have to put placeholders on this one because you probably don't know them. If you know what the placeholders are going to be, you can put them. But if you know what the placeholders are going to be, then you probably don't actually need them there. So most of the time, this part is just left blank. And if you didn't leave enough space, you can always just erase your minus y cubed and move it further down. All right, so you are looking for what multiplies by x to give you x cubed. X times x squared is x cubed. Then you're going to multiply x squared by this whole thing, x minus y. So x squared times x minus y is x cubed minus x squared y. When you're doing division, you always subtract. So we're going to change our signs. And this one should always cancel out. And so there's nothing up here, so we just have an x squared y. So x times what gives us x squared y? Well, that should be plus xy. Then you're going to take xy and multiply it by this x minus y. So it should give you x squared y minus xy squared. Again, you change your signs because you're subtracting. This term here will cancel, and then we don't have anything up here, so it's just xy squared. Then we repeat. You do the same thing every time. X times what gives me xy squared? Plus y squared. So y squared times x minus y is xy squared minus y cubed. So again, you change your signs because you're going to subtract. And these terms up here cancel. And then we have negative y cubed plus y cubed. That is a 0. So we have no remainder. So that means that this up here is our answer. So that's how you would do long division using polynomials. Going to one more concept review question. We want to solve for our points of intersection. We have a circle and a line. X squared plus y squared equals 9. That's a circle with a radius of 3. And then y minus x plus equals 1. You could say y equals x plus 1. It's going to be a circle and a line. So a circle and a line don't have to intersect. They could look like that. So we could have no solution. They're not usually going to give you one like that. You could have your circle and your line, whoops, they should be tangent. they touch at one point, that would be ideal. Typically, they don't give you that one either. Circle and a line, you're probably going to have two answers, two intersection points. So on this one, we're going to use substitution. And I'm going to say for this bottom equation, solve it for y equals x plus 1, and plug that in right here. So x squared plus, instead of y, put x plus 1 squared equals 9. So distribute right here, you get x squared plus x squared plus 2x plus 1 equals 9. I'm going to combine my like terms and put everything on the left side and hope that it factors. So 2x squared plus 2x minus 8 equals 0. We can divide all of those by 2. And you're wanting to hopefully factor it. And unfortunately, it does not factor. So you can either use completing the square or quadratic formula from here. I personally prefer quadratic formula, so that's what I'm going to default to. But if you prefer completing the square, feel free to use that. So if you plug it into the quadratic formula, your x value is going to be -1 plus or minus the square root of 1 plus 16, so that should be 17 over 2. So those are actually, that's actually two x values. So those are going to be put into two different ordered pairs. And I like to make it into a separate fraction, so -1/2 plus the square root of 17 over 2. I like to make it two fractions over here. I think it makes it a little bit easier on the next step that we're about to do. And then -1/2 minus the square root of 17 over 2. So those are your x values. Now you need your y values. Easiest way to get your y values is to plug into this equation. So -1/2 plus the square root of 17 over 2, that's our x, plus 1. Well, we can't really combine a radical and a 1, but what is -1/2 plus 1? Hopefully you said 1/2. So 1/2 and then plus the square root of 17 over 2. For the other one, the other x value is -1/2 minus the square root of 17 over 2. And then x plus 1 from our equation. So again, we can't combine the radical, but -1/2 plus 1 is 1/2. So we have 1/2 minus the square root of 17 over 2. And so this would be your answer. And you do have to have both of the points correct in order to get the question right. Okay, so that's how that works. You did that in Algebra 2, and you did it last year in pre-calculus, so hopefully you remember it a little bit. Now we're going to move on to the graphing calculator. So we want to use the graphing calculator to find the zeros of the polynomial function. So here's my calculator. Whenever we're looking for zeros of a function, we're going to go to y equals. So first off, turn on your calculator. That's the bottom left button. And then up at the top, separated from everything else, there is a y equals button, and you're going to hit it. And it should come up like that. The calculator that I have pulled up on the computer is a color version. The ones that I have in class are not, so you're not going to see a bunch of different colors. They're just going to be grayscale and pixelated. But you're going to type in that equation. So your x is right next to the green button that says alpha. Do y'all see x, t, theta, and n? You're going to click that button, x, and then squared minus 3. And you're going to go back and hit that x, and then plus 1. So once you have that entered, you're going to hit enter, and it'll go to y2. We only need the first y1. It should be where your equal sign is dark. So hopefully you see that. Once you have that, you're going to go over to graph, and it'll graph it for you. If your graph doesn't look like that, go over to window, and you want your x min to be -10. So I'm going to graph for you real quick. Your x min is from here, your x max is to here. So we're going to go from -10 to 10. That's what we're going to say our window is. So -10 to 10, min and max. And then the scale is just how often they put a tick mark. And so 1 means they're going to put a tick mark at -9, -8, etc., all the way to 10. Y min is going to be -10. Your Y max is also going to be 10. That's normally what I'm going to do for my window, -10 to 10, with a scale of 1. And if you need to adjust it, you can, and it's easy to do. You just go to window and you click there. You don't need to worry about X resolution or these other two if they show up. Just ignore those, leave them as whatever they are. Just work on the X min, the max, and the scale. And that's just how often you have tick marks. That's all that the scale is. So that's your graph. We're looking for the zeros. To find the zeros, we're going to go to calculate. So right next to graph, you should see the trace button. And in blue above it, it says calculate. To get to that, you're going to hit the second button, which is blue, and then you're going to hit the trace button. And so it should come up like that. And we are looking for zeros. Which number are we going to pick, probably? You're going to pick 2 because it says 0. So you can either arrow down and then hit enter, or you can just hit number 2 because that's what you're going for. So it says left bound, and then it's going to come up and say right bound. I'm going to come back over here real quick on my graph. There's my graph, basically. This is a 0 because that's where it crosses the x-axis. Here's another 0 over here. That's where it crosses the x-axis. We need to get to the left of this point and then to the right of this point. So anywhere over here would be to the left of it. Anywhere over here would be to the right of it. But we don't want to go past that other 0. We want to only encompass 1 0. So I am currently to the left. If you want, you can press your left arrow and go further away. It doesn't matter. But you want to be to the left of the point. Once you are, you hit enter, and then it goes right bound. So again, you want to get to the right of it. Once I'm right there, it looks like I'm to the right of it. I'm going to go a little bit further. I can keep going, keep going. Just don't go too far because you don't want to get past the other 0. So I'm going to say there. And then it says guess. We want to get it kind of close. We say it's right there. It doesn't have to be exact. You just want to get it close to the one that you're looking for. And it says that the 0 is 0.381966. We always round to 4 decimal places in calculus. So 0.3820 would be one of your zeros. And then there's going to be another one. We're going to go back and repeat the steps. So if you think you can do it by yourself, go ahead and try. But you're going to do second and then calculate. You're going to hit 2. And so we already did this one over here. So we're going to go to the left of this next point. So I got to go right a little bit. So there's the left bound. And then there's the right bound, and again, guess. And if you know that you only have 1 in between it, you actually don't have to move it. Whoops, sorry, I went too far past my bound. Let me go back. Left bound, we'll put it here. Right bound, we put it over here. And I'm not moving the cursor for the guess, and it'll still come up. So you can't go past your write bound. That's what happened on the other one, why it messed up. But that should give you 2.618034. So our other 0 is 2.6180. So those are your zeros. And I think that the answer key will give you the long decimal of it. It may round it to 4 now that I'm thinking about it. I'm not sure. But for your test and for your homework, I'm only going to be looking for the first 4 decimal places. So you don't have to write it out nearly as far as the book is going to take it. Okay, so we're going to look at one more example with the calculator. It wants us to find the points of intersection. So if you look, it says y equals x squared minus 3x plus 1. That's what we just had in the calculator. So we don't need to retype that one. It's already in there. You're going to go back to y equals. And don't erase that one because that's the same equation. Hit enter and get to y, or go down and hit to y2 and type in x. Again, that's next to the green alpha button, plus 1, and then hit enter. So both of them should be darkened on the equal sign. And then you're going to go to graph. And again, if you're using one from the classroom, it's just 2 gray black lines. They're not going to be colored. If you got the color version, then it will be 2 different colors. So we're going to go again to calculate. So you're going to hit the blue button and then trace. It's calculate. And which one do you think we're going to want to pick? Intersect, number 5. So again, you can just click 5. You don't have to scroll down to it. It says first curve and second curve. We only entered 2 equations. We did a y1 and a y2. So on first curve, you just hit enter. And on second curve, you hit enter because you only had 2 options for it to pick from. So you can change it, but it's just going to switch which one was first and second. And it doesn't matter when you're talking about where they intersect. And then it says guess. Now on this one, you do need to get it close to an intersection point because there are multiple ones. And my cursor happens to already be near what it looks like to be an intersection point. So I'm going to hit enter. And it says, oh, that was exactly what it was. 0, 1. So one intersection point is 0, 1. And then we have to go back to calculate and do intersect again. So again, first curve, second curve, you just hit enter and enter because we only have 2 in there. Now I need to move my cursor, and it looks like it's about right there. You don't have to be super accurate. You do want to be close. So if I put it there, it should still pull it up. And it says that the intersection point is 4, 5. So those are the 2 intersection points that we have between our parabola and our line. And so that is how you do those problems on the graphing calculator. So if you do not have a graphing calculator at home, when it comes to your homework tonight, you need to make sure to do problems 10, 11, and 12 now before you leave, before the bell rings, because those say use a graphing calculator to do it. You can possibly get an app on your phone. You may have to buy it. Sometimes they're free. But if you want to look on your phone, not now, you're at school, later when you get home and when you have hopefully Wi-Fi so that you're not downloading and using a bunch of data, you can look for an app and see if it's available in the Google Play Store or the Apple iTunes Store. And you're welcome to use that at home. However, in class, you have calculators available, so that's what you should be using, not your cellular device. So hopefully that helps you with lesson 2.